This note packet is going to pick up from the notes that we started in class last time. So just fill in. Starts with day 2 because this is the second day, and then after you guys are finished filling in these notes, you can head back and work on your homework and then work on your LTAs. Math homework. You should be working on math homework. Alright, day 2. So we've added matrices, we've subtracted matrices, we can also multiply matrices. And like I said, multiplication is where it starts to get complicated, but before we have the complicated multiplication, we have the easy multiplication. So when a matrix is multiplied by just a constant, it's called scalar multiplication. S-C-A-L-A-R. So we're not multiplying two matrices together, we're multiplying a matrix by a number. And we're just going to multiply each element of the matrix by that constant that's on the outside. It's just like the distributive property. So looking at this first example, we have the matrix A, which has 4, 6, 2, and 8, and we're doing 3 times A. So 3 times A is just 3 times this matrix. And I'm just going to multiply every element on the inside by 3. So 4 times 3 will give me 12, 6 times 3 is 18, this will give me 6, that'll give me 24. Alright, pretty straightforward. For number 2, same thing. I've got 1/2 times A. So 4, 6, 2, 8. Now, it would be kind of silly, but this could have been written as A over 2. Alright, dividing by 2 is the same thing as multiplying by 1/2. It's just kind of easier to see if it's written by multiplication. So 1/2 times 4 will give me 2. 1/2 times 6 is 3. That's 1, and that's 4. And for number 3, they just threw a negative on the outside, but it is the exact same. And if you don't want to like recopy the matrix, that's fine. I think it's helpful, but that's just me. Alright, so pretty easy. Shoot. We can also have matrix equations, and a matrix equation is just an equation in which the variable that we're solving for is a matrix. Alright, and remember, matrices are represented with a capital letter, so if you look at the 2 examples below, it's capital X instead of a little x. But we're going to solve it exactly like we would have solved all those other equations. So looking at the first one, I've got x minus this first matrix is equal to this matrix. So I want to get x by itself, so what am I going to do? I'm going to add to both sides. So I'll add this matrix. Those cancel each other out, and then I will add it here. Here it's kind of weird because if you look on this side, we're so used to putting everything, under each other, writing it vertical, but to me, writing matrices, it's easier to write it next to each other because it's easier to line up the elements. But still on the left side, we're just left with capital X, and then on the right side, you're just going to add the corresponding elements. So 0 plus 1 is 1, 1 plus 1 is 2, 8 plus 3 is 11, and 9 plus 2 is 11. Easy peasy. Number 2, I've got x plus some stuff, so I'm going to subtract it from both sides. So those would cancel, and I'll do it over here too. So we are going to get 11, 7, negative 6, and negative 1. Alright, so remember, you just do the corresponding elements. So 10 minus negative 1 is how I got 11, 7 minus 0 is 7, so on and so forth. Pretty easy. They can get a little bit more complicated, alright, so involving that scalar multiplication from like 2 seconds ago. But exactly how we would do things from the past. So I want to get x by itself. Well, the first thing I'm going to do is I'm going to distribute this 2 into my matrix. So this is going to be 4x plus, and then this is going to be 2 times 3, so that's 6, 8, negative 4, and 2 equals. And then I'm trying to get x by itself, so I'll subtract this matrix from both sides. And this is going to go into this space, but whatever. 6, 8. So now I've got 4x will be equal to, and 10 minus 6 is 4, that's negative 8. 4 minus negative 4 is positive 8, and 2 minus 2 is 0. And then I'm going to divide both sides by 4, and remember, dividing by 4 is the same thing as multiplying by 1/4. It's kind of weird if you write that. You're not ever going to see that anywhere. So I would just multiply both sides by 1/4. And that's something that you guys should get in a habit of doing with calc. Usually we write multiply by fractions instead of dividing. So then we get that x is equal to 1, negative 2, 2, and 0. Alright, so really we've been doing some easy stuff. This is old, just using, the little matrix things of, using the right elements and stuff. I'm going to erase this. This one will be done the same way. Let me point out, because I haven't pointed it out, the dimensions of this would be a 2 by 3. Alright, rows and then columns. So I'll subtract from both sides. Those cancel, so I'm left with negative 3x. And that is going to be equal to 3, 0, 9, negative 21, negative 15, and 6. Make sure you're keeping track of your negatives. And then we can divide both sides by negative 3 or multiply both sides by negative 1/3. And we get that x is equal to, be careful, you're multiplying by negative, so all the signs are going to change. So that's going to be negative 1, 0, negative 3, 7, 5, and negative 2. Right. Easy peasy. Moving down, this doesn't really have anything to do with scalar multiplication or equations necessarily. I mean, these are equations, they have equal signs. So the important thing is that if these two matrices are equal to each other, obviously that means everything is the same. They're equal to each other. If you look, I've got a 4 in my 1, 2 place. So I've got a 4 in my 1, 2 place. I have a 3 in my 2, 1 place. I have a 3 in my 2, 1 place. So if I'm going to solve these for x and y, well, if I have a 2x minus 5 here, that obviously has to be equal to 25 because those elements are in the exact same place. So to solve for x, we're just going to say, okay, well that means that 2x minus 5 has to be equal to 25. This is as easy as it gets. Solve for x, add 5 to both sides, divide by 2, get that x is 15. And we can do the same thing for the y's. If this is in the position 2, 2, and this is in the position 2, 2, they're going to be equal to each other. So 3y plus 12 is equal to y plus 18. That will give me 2y is equal to 6, I believe. So y is equal to 3. And part B is going to be done the same way. These matrices are equivalent to each other, so their elements have to be equal when they're in the same place. So x plus 8 is going to be equal to the 38. So x plus 8 equals 38. So x equals 30. That was super easy. And then negative y is going to be equal to 4y minus 10. I'm going to put the y's on the right side just because it's weird. So y is equal to 2. Alright, so again, we're starting off pretty easy, and I'm pretty sure that's it. Yep, that's day 3, so you guys are done. Head on back, work on your homework.